transfer. Switching angle between normal and inter is 45 degree, and again between inter and transfer is 45 degree. There are number of ways 11. In normal position, there are one, and in inter position there are one contact, and normal inter position there are four contacts, and inter and transfer position there are four contacts, and in transfer position there are one contact, as shown in this figure. The contact distribution for NIT switch has been shown in this figure. For normal position, contact 1 and 2 is taken for annunciation circuit. For normal and inter position, there are 4 contacts, 3 and 4 taken for main CB TC1 circuit. 5 and 6 for normal and inter position is taken for main CB TC2 circuit, and 7 and 8 for normal and inter position taken for main CB closing interlock circuit. 9 and 10 is taken for 2 annunciation circuit. For inter and transfer position there are again 4 contact, 11, 12, 13, 14, 15, 16, 17, 18. 11, 12 are taken for TBC CB TC1 circuit. For inter and transfer position 13 and 14 is taken for TBC CB TC2 circuit, and 15 and 16 taken for TBC CB closing interlock circuit. 17, 18 is the spare contact. 19, 20 is for only interposition contact, is not taken for any use. 21 and 22 is taken for annunciation circuit, it is contact for transfer position. Now, to understand the uses of NIT switch, let us take a simple example as shown in this single line diagram. Here are 2 feeders and one bus transfer bay. There are one main bus and one is transfer bus. Now, feeder 1 is supplying power through closing of 89B and 89L and closing of circuit breaker of its own bay. 89B is the main bus side isolator, 89L is the line side isolator, 89T is the transfer bus side isolator. Now, for maintenance purpose, the CB required shutdown. Therefore, in control room there are 3 panels. One is for feeder 1, one is for feeder 2, and one is for bus transfer panel. Now, without shutdown, we have to switch over the feeder 1 to bus transfer bay. Therefore, there will be no power interruption. First, we have to close 89T of transfer bus side isolator, and also we have to close 89B and 89T of bus transfer bay. Then we have to move the NIT switch to inter position of feeder 1 panel. After moving the NIT switch to inter position of its own panel, then we can close the bus transfer breaker from control and relay panel of the bus transfer bay. After closing the bus transfer breaker, the feeder 1 is getting power from bus transfer bay as well as from main bus. Then we can take the shutdown of the circuit breaker of its own bay. After that, the breaker of its own bay can be switched off, and isolator 89B and 89L can be opened for maintenance of the circuit breaker. And after that, the NIT switch is transferred to the transfer position so that the protection strip of the control and relay panel of feeder 1 can be transferred to the circuit breaker of the bus transfer bay. Since the strip of the protection panel of feeder 1 is transferred to the breaker of the transfer bay, that is why it is called trip transfer switch. It is always to take the position to transfer position, otherwise if it is remain in interposition, if any fault occur, the breaker of the own CB and also breaker of TBC CB will be tripped simultaneously. Now the normal inter contacts 3 and 4, 5 and 6 and 7 and 8 has been shown in this diagram. 3 and 4 and 5 6 is taken for CB protection trip of its own way to TC1 and TC2 respectively by means of 86 NO contact 3 and 4 and 5 and 6 respectively. Whenever a fault occurs, relay will send a trip signal to 86. 86 will operate and will make its NO contact to NC to energize the trip coil 1 and trip coil 2 as shown in this figure. Also 86 NC contact by means of NIT switch 7 and 8 taken to CB manual closed interlocking circuit. It is taken as whenever 86 is operate, we cannot close the circuit breaker. Contacts 11, 12 and 13, 14 for inter and transfer position has been shown in this diagram. Here contacts 11, 12 and 13, 14 for inter and transfer position has been taken for bus transfer circuit breaker TC1 and TC2 circuit respectively by means of 86 NO contact 7, 8 and 9 and 10 respectively. Whenever the NIT switch in transfer position, in fault condition 86 will operate and it will send to trip signal to bus transfer breaker by means of 7, 8 and 9, 10 of the 86 contact as shown in this diagram. Again, contact 15 and 16 for inter and transfer position is taken for TBC circuit breaker closing interlock by means of 86 NC contact 11, 12. That is, if 86 is operate and transfer NIT switch is in inter or transfer position, we cannot close the TBC circuit breaker. The contact 1 and 2 and 21 and 22, it is contact for normal position and transfer position respectively is taken for annunciator, that is TTS position is wrong, that is trip transfer position is wrong. Whenever 89T, that is transfer bus side isolator of its feeder is in open condition but the NIT switch position is normal condition, there will be no annunciator to DTS position wrong. But if the NIT switch is transfer position but 89T in open condition, it will show the annunciation TTS position wrong to the operation staff. Again, if the 89T is in closed position but NIT switch position is in normal position, it will also send annunciation to the operating staff to TTS position wrong, that is the operation is wrong. The right operation is the NIT switch will be in normal